Okay, guys, Unit 4, little mini unit here, or Chapter 4 from the textbook. 4.6 exactly, page 270-ish, 73, 74. Trig identities. I know some of you were all over it today, some of you were having issues. The identities, Pythagorean identity, the quotient identity here, the reciprocal identities here in purple. So these are what I'm going to refer to, and what I'm going to do is I'm going to just leave this page as is, and I'm going to do homework questions from the textbook. So the first couple will be a little bit easier, and then we'll jump around. So the first one is prove that sine theta is equal to cos theta, tan theta, and one thing we'll do with the qi is get rid of our tan. So when we see tan theta, we will get rid of it, and we'll go cos theta is this equal to, or sorry, cos theta is, so this is the right side, and get rid of tan, change it into sine theta over cos theta, and you could write qi here if you'd like, so you know what you're doing. These cancel out, and I'm left with just sine theta. So I'm left with left side equals right side. Same with, so if I get to 3b, we're going to throw this in here. Cosecant theta is secant theta, cotant theta. So we'll change these. All these are, that's 1 over cos theta. That's 1 over tan theta. And then that is, we're going to multiply those. So that gets a little messy here. That becomes 1 over cos. 1 tan is sine cos. So all of these are on the bottom here. So this will cancel out with this. Really strange type of multiplication, but just the rules apply. 1 times 1 is 1. And then if I just left this, this would be sine cos. Those are on the top. So this sine and this cos are on top. This cos is on the bottom. Those cancel out, and I end up with 1 over sine, which is in fact cosecant theta. Okay, so there's that one there, and let's keep going. Let's play around with the other ones. I think you can get 3C looks good, 3D. Let's move on to 4. We'll do 4A. We'll expand the right side in 4A, and we'll get cosecant A plus sine cosecant A. So that is what we have on the right here. And that becomes, I want this to equal, sorry, the left side was 1 plus cosecant A. So you look at this here and you say to yourself, well, hold on a second, there's cosecant A, there's cosecant A. This has to be 1 then, and it is because that's sine A. Cosecant is 1 over sine A. And then these cancel out, and you're left with 1 here. So then that's just cosecant A plus 1, and that's left side equals right side. So that's a bit messy. We can move further. Those are all the same. Number 4, really, you just have a lot of expansion. Let's get to 5. It gets a little fun. 1 minus sine squared theta is equal to sine cos cot. So this guy here, you're going to notice that this is going to be the same. Pythagorean identity is going to tell you that this is the same as cos squared theta. Let's clean up this. Sine cos cot is 1 over tan, which is the same as, so cot is 1 over tan. 1 over tan is, if you remember, 1 over sine over cos, or cos over sine. Okay, so you can do it one of two ways. One is to say that if tan is sine over cos, then 1 over tan is cos over sine. That's one thing to do. Another way is to write this as 1 over sine over cos, and that is 1 times cos over sine once you flip the bottom, because that's dividing by sine over cos. So you flip it, you get cos over sine, and then that cancels out with that, and then you're left with cos squared theta, which is equal to 1 minus sine squared theta, by the Pythagorean identity. So this was quotient identity, that's Pythagorean identity, and that's left side, right side. Okay, and then let's look at this next one. 6, I don't do 6. If I said to do 6, don't do it. We're not going to use that particular identity. 7 is our friend, the DOS. I know when you saw difference of squares as a child, not as a child, but as a grade 10, you must have thought, wow, that's kind of cool. Little did you know that it would come up and bite you as you move through grade 11. But it's come up a few times to be a little tricky. Well, it actually helps us solve things. So let's look at it from the positive point of view. Anyway, anytime you see the plus in the denominator, you're going to use a difference of squares. So this becomes, what you're going to multiply by is 1 minus sine theta. Use the power of difference of squares to help solve this. And then the left side says left side equals. Keep going here. I'm not going to multiply out on the top. Don't do that because you'll see in the why that is in a second. So 1 plus sine theta times 1 minus sine theta, different squares, says square this and then subtract the square of this. So the square of sine theta is sine squared theta. Don't put a square on the theta. So that is equal to, there's Pythagorean identity, 1 minus sine squared theta. You're always looking for your ones. See if that can help you. And that's cos squared theta, cos theta, 1 minus sine theta. And now this is the same. I have 1 sine cos theta on top. I have cos squared theta on the bottom. So that's the same as if I had this. That would cancel out to 1 over x. And that's what happens here. That cancels out to 1 over cos. And now I have 1 sine theta over cos theta. And that's what I had on the right side. That's what I want. So that's how you prove that guy. And more of the same for 8, really. There. So let's look at some of the sheet work. So give me a second. Let me find. So some of the sheet stuff here. Let me just take, since this is a practice apply and solve sheet. And if we look at B, for example, 6B, I believe I call this 6B. I have some of this stuff's straightforward. Maybe I shouldn't do this one. Anyway, we'll do it. Cos theta is equal to sine theta 1 subtract sine squared theta. Immediately I look down here and I see 1 sine squared theta. I look at this and I want to replace that with cos squared theta. And somehow we're going to make this look like this. And you can do that a couple ways. One, if you can remember that sine over cos is tan, then you can go right here. Or on this side, what you can do is go sine over cos over cos. So that's sine over cos times 1 over cos. So that's how that cleans up. And that's sine over cos squared. And then we're done. Okay, so then, or you could rewrite this as 1 over sine squared theta and then make it look exactly like this. Okay, so that's that. What else do I want to look at? D, blah, blah, blah. Oh, the difference of squares ones are good. So, or not different squares, the folding ones are good. So 7C, I had this cos squared x, and it's the same as theta. 1 minus sine x, 1 plus sine x. So I go through it is equal to that. I FOIL this side to get 1 minus sine x plus sine x minus sine squared x. So I look at this and I want cos squared theta here, and this kind of works out nicely. That's minus sine x plus sine x, so that's 1 minus, so I'm left with, this turns into 0, so 1 minus 0 just disappears. And then I have 1 sine x, sine squared x, pi will tell me that, not equal, pi will tell me that that's cos squared x, and that's what I wanted. Okay, and then if we want to try some of the harder stuff on the front page, or sorry, on the other page, so this is Thursday's homework, the 10.8 page, exercise 10.8. We can look at things like, I don't know, here's 5. Cosecant t over secant t is equal to cotangent t. Well, cosecant, so this is dividing, right? So this is, on top here, I'm going to have then 1 over sine t over 1 over cos t, which is the same as 1 over sine t. So the bottom goes to the top here, right? The bottom of the bottom goes to the top, so that's cos t over 1. So when you divide by 1 over cos, the same as multiplying by cos over 1, and that's cos over sine, which is 1 over tan, right? Because remember that sine over cos is tan. So it's 1 over tan, the reciprocal, which is cot t. Okay? And I should have put t's everywhere. And that's that one. Let's keep going. I'm sure you're having a blast. Look at, I don't know which one. Oh, goodness. Which one did I say to do? What was that? I'm boring myself here. Let's look at 10 or 9. We'll call it a day here. 9 is cos squared t is equal to sine squared t plus 2 cos squared t minus 1. So I look at all this, and that kind of, I can break this down. 2 cos t, that doesn't come up. So that's the same as this, plus cos t plus cos squared t plus cos squared t minus 1. So when we have this 2 cos squared t, that's the same as saying 2x, and that's x plus x. So 2 cos squared t is cos squared t plus cos squared t, and that's what I have here. And the reason I did that is because I see sine squared t, I see cos squared t, and I think to myself, hold on a second, there's pi, Pythagorean identity, and I will use that. That's the same as 1. And then I have cos squared t minus 1. 1 plus 1 minus 1 is 0. Look at cos squared t, and I'm all done. Okay, so that's about it for all this stuff here. Take a look at this over the next couple days. Little quiz coming up in a couple days, and just keep working on it. Do a bunch of these, and you'll be great here for the test. Take care.